Hi, we're going to be finding the volume of regular shaped prisms today. Regular shape means that all of the sides of the prism are the same. So this is a pentagonal prism, and this one is 1, 2, 3, 4, 5, 6 sides. So this is a hexagonal prism. Before we start looking at the prism, let's just go back and look at the two-dimensional shape here. So when we're looking at the two-dimensional shape, this is a hexagon. We need to really just think about it as 6 triangles. 1, 2, 3, 4, 5, 6, and the shape of each of those little pieces is a triangle. And so whenever we're dealing with a triangle, we need the two numbers that are perpendicular. So this would be 12, and then the altitude of this is 10.39. We divide by 2 because all of these shapes are triangles, and when you have a triangle, your rule is length times width divided by 2. So this would be a pentagonal prism. So in this shape, you can kind of see they've dotted them in. It would be 5 triangles. We just looked at this one. This one is 6 triangles. This one right here is an octagonal prism. So this would be 8 triangles, and so on. You could have any number of sides. So when we up it to actually having a prism shape, a 3-dimensional shape, these were all flat 2D. This is now 3-dimensional. We just need to remember to multiply by the height. And the height of these shapes is defined as the distance from pentagon to pentagon, the face that names the figure. So this one is pretty obvious that this would be the height. But when they flip the figure, it's a little bit harder to realize that this dimension here, whatever that is, would be the height, because it would be the distance from, I guess this looks like an octagon, from that octagon to this octagon too. The face that names the figure, okay, is the bases of it. So the height would be the distance from there to there. So let's go ahead and practice a couple. So this is a pentagon. I'm going to draw lines from the center to the corners, and I'm going to understand that this is one triangle right there. So I have 5 triangles, and those triangles are each 4. I'm going to kind of enlarge that piece right here. This is an enlargement of it. That is 4. All of these would be 4. And then it says the distance perpendicular. Can you see that little square right up there? Is 2.75. So it's 4 times 2.75. And I'm going to divide by 2 at some point because these shapes are triangles. That would give me the area of the base. That would give me the area of this whole zone that I have in red. But we don't just have a 2-dimensional figure. We have a 3-dimensional figure. So we need to say that we have 28 layers of that many cubic square inches. We have 28 layers of that. And we would multiply that all out together. I did that earlier. When I am multiplying, just to let you know, I kind of extend this out, and I multiply all the way across the top, and I divide by 2 at the end. So you can divide by 2 whenever you want. You could do it in the beginning, you can do it in the middle, you can do it at the end. I tend to do it at the end. I think of these as just being fractions, and I multiply across and then divide by 2 at the end. So this ends up giving me 770 centimeters cubed when I push those buttons on a calculator. Again, this right here is the number of triangles. This right here is the area of one triangle. And this right here is defined as the height. I'm going to put that in quotes because remember, the height is defined as the distance from pentagon to pentagon, or from hexagon to hexagon. It won't always be going vertically. On your homework assignment today, you're going to see that this one here is the height. I know it doesn't seem like it, but the artist chose to draw this one laying down. Okay, on this one here, the question asks, which one of these would be considered the height of that prism? Let's try it one more time with a slightly different shape. This is a hexagonal prism, and I realize these numbers are really hard for you to see. Okay, This right here is 12, and then the dotted line is giving you the perpendicular height, which is 10.39, I believe. Let me check my other key. Yep. Okay, let me count how many triangles I have. One mistake that I see is sometimes kids think of this as two triangles. Now this is one triangle just with the altitude drawn in. So you're really counting sides of the shape, sides of the shape. So this one is 6. That's the number of triangles. And then each of those triangles is 12 by the perpendicular height of 10.39. I divide by 2 because that is the rule for a triangle. So that is the area of one triangle. And then the height, again, is pretty easy. This kind of looks truly like a height. That is the 24. Okay, and again, I like to multiply straight across and divide by 2 at the end, but you can divide by 2 whenever you want. I did that earlier, and I got 8,977 centimeters cubed. Go ahead and try it on your calculator on your own, and let me know if you need any help with that. So the number of triangles, the area of one triangle, timesing it by the height.